Hi everyone, in this lesson we are going to break down two ideas that confuse a lot of students in chemistry: isotopes and relative atomic mass. By the end of this lesson, the numbers on the periodic table will finally make sense. Isotopes are atoms of the same element that have the same number of protons but a different number of neutrons. Because neutrons add mass, isotopes have different mass numbers. But because protons stay the same, isotopes are still the same element. For example, carbon always has 6 protons, but it can have 6 neutrons, making it carbon 12, 7 neutrons making it carbon 13, 8 neutrons making it carbon 14. Isotopes are atoms of the same element with the same number of protons but different number of neutrons. Chemically, isotopes behave almost exactly the same. That is because chemical reactions depend on electrons, not neutrons. Since isotopes have the same number of protons, they also have the same number of electrons. Physically, isotopes can behave differently because of their differences in mass. For example, isotopes can exhibit differences in density, diffusion speed, and existence of radioactivity. If isotopes have different masses, a question appears: which mass do we put on the periodic table? The answer is, we don't pick one isotope. Instead, we calculate an average mass based on how common each isotope is. This average mass is called the relative atomic mass. What is relative atomic mass? Relative atomic mass is the average mass of an element's isotope, taking into account their relative abundances. Relative abundance simply means how common each isotope is in nature. Isotopes that are more common affect their average more. Calculate a real example using chlorine. Chlorine has two main isotopes: chlorine 35 with a relative abundance of 75% and chlorine 37 with a relative abundance of 25%. Firstly, multiply each isotope's mass by its abundance. 35 times 75, then 37 times 25. Next, add them together. 2625 plus 925, you get 3550. Finally, divide by 100. So 3550 divided by 100, you get 35.5. That is why chlorine's atomic mass on the periodic table is 35.5. The decimal tells us isotopes exist. The decimals for the atomic masses indicated on the periodic table indicates that that element represented as isotopes. Take note, mass number is not the same with the relative atomic mass. The mass number only represents the sum of the proton and neutron in the nucleus of an atom of a particular element, while the relative atomic mass is the average of the masses of all the isotopes of that element that exist. Also, the masses seen on the periodic table is actually the relative atomic mass. It is not the mass of a single isotope. In our next video, we'll look at electron shells and electronic configurations. Please like, share and subscribe if you learned anything in this session.